And just to give you an introduction about our first company, the parent company, Vorsteiner, we've been around for 15 years today. And we are a tuner specializing in mostly modern European cars. And we actually are a manufacturer of carbon fiber composites and wheels. And we manufacture all these parts actually in our facility in Orange County. So some of the makes that we focus on besides Porsche, we do Lamborghini, McLaren, Ferrari, Bentley. We currently sell and export to 50 different countries worldwide, and we're also a TÜV-approved manufacturer. So we completely design and manufacture all of our products in-house. We do the tooling and the production and the painting. And we use a lot of the latest technology, 3D printing, CAD, laser scanning, clay modeling to sort of develop all of our products. And you see here, right here is a Porsche GT4 that we developed some new carbon fiber aero pieces for. And we actually CFD all of our products to make sure that they're actually functional and generating downforce and reducing drag. So this particular GT4 went around thermal, and we shaved a full second with the additional aero components that we put on the car. And next slide, Amjad. So why Porsche? You know, I get to drive Lamborghinis, Ferraris, McLarens, and you know, I've driven and owned a lot of nice cars, and I always go back to Porsche. And the reason is, whenever you get into Porsche, it's to me, the only modern manufacturer today that actually builds a car that you feel connected to the car. You feel like you're driving the car instead of the car driving you. So, you know, Lamborghinis and McLarens, they're very, very fast, but you don't feel like you're actually engaged to the car. There's like a computer filter between you and the car. And Porsche is the only one that's really been able to sort of keep the essence of that purest driving experience, like the new GT3s and the new GT2s. The driving ergonomics are just fantastic. When you get into Porsche, it just everything, all the buttons, the steering wheel, the positioning, everything is just right there. When you get into Lamborghini or McLaren, there's always this adaptation where you're like, oh, where's the window switch? Where's the gear knob? There's something that you always have to constantly adapt to. But with Porsche, you just sit inside and it just immediately, everything is just sort of placed exactly where it needs to be. The other thing I like about Porsche, especially the GT products, is they're very, very focused on power to weight ratio. So you see a lot of high horsepower cars, but for some reason Porsche, like for example a Turbo S, even though it's rated lower horsepower than their competitors, they're able to produce better quarter mile and 0 to 60 times because Porsche has figured out how to translate that power onto the road and make it very, very efficient. So power to weight to me is a very, very big, important topic that Porsche has really have mastered more than any other manufacturer. And the car really just becomes an extension of you, and Porsche's no compromise approach to the driving experience. I feel like with other manufacturers like BMW and Mercedes, they've sort of made the car so compliant, so comfortable that there is compromises you make. When you make things more comfortable and more compliant, you lose that connection with the car. And Porsche sort of kept that essence, even to cars today. So you know, we're kind of in this generation where we're seeing this analog to digital phase, you know, and digital, we go in even as far as like, we're talking about cars like Tesla that are full electric cars, autonomous cars, and I have two sons, 5- and 6-year-old boys, and I'm actually worried that in 10 years that they won't need a driver's license anymore because they're just going to summon the car on their phone, the car's going to show up, and it's going to be completely autonomous driving, and there really isn't a need for driving anymore in the future. Driving maybe will become like a hobby and a sport, just like shooting or playing golf. Driving in the future will become something that is something people want to do as a hobby, not a necessity. So transportation concept is really changing. And in between that, we have, what I wanted to do was create an analog car in a digital world and sort of bridge that gap. Because a lot of times you see classic Porsche owners or classic car owners, they love the way the car looks in their garage, but they take it to the office on Monday and they're like, oh my God, I really miss my Bluetooth, I really miss my radio, I wish the car had a nose lift system so that if there was a steep driveway, I wouldn't crack the front bumper. So what I wanted to do is try and keep the essence of the analog air-cooled cars, that emotional engagement and that connection you have with the car, but use modern technology to enhance that driving experience and make it more enjoyable. So our car has a lot of those modern conveniences added to it without losing that essence of that Porsche 993. So here's some sketches of the car we did initially. That's actually not my hand. I have really stubby, ugly hands, so I actually hired one of my employees to pose in this photo right here. So this is kind of where it all started. We started with a Porsche, 1995 Porsche 993. And what you see on that car is this white powder that we spray all over the car because we can't have a reflective surface to be able to capture the scan data on the car. So we want the car to have this sort of a matte texture so that it's not reflection. And then once we spray the white powder, we put these tiny white dots on all different points of the car, which creates a scan data reference point. And that is actually an armature that houses a carbon fiber blue light laser scanning tool. This is actually the kind of technology that Porsche actually uses themselves to manufacture and develop all of their cars. So this is an example of the blue light laser scanning here, and you can kind of make out some of these dots. Those are the white sticker dots that we put throughout the exterior and the interior of the car, and we've basically scanned the interior and the full exterior of the car to get complete data. And this is sort of what the computer spits out, is the surface data of, you see the door and the rear fender right here. And once we take this data, we start actually designing our products in CAD. We use a software called CATIA, which is actually the same sort of software that Porsche uses to develop all their cars. And this is sort of how it all started. So what we wanted to do, when we talked to Jeff Gamroth here, who is the engine builder, the number one thing he emphasized on the Porsche 911 is you've got to get that track as square as possible. So 911s have a tendency where the rear track is slightly wider than the front, and what that creates is understeer. So we wanted to minimize that understeer and create as much of a neutral steering feel as possible with absolute, maximum handling. So what we did is we created a three-piece forged mock-up wheel for all four corners, and we used the outer suspension points of the 993. So a lot of people don't know this, but on the 964s, right, and the 993s, there are two suspension mounting points on the front of the car. A lot of people don't know this, but Porsche had created this outer suspension mounting point because that's what they use in all of their race cars. And in order to use that outer suspension point in the race cars and follow the rules and have homologation, they had to have it on all of the production cars. But none of the production cars, of course, that you see and you drive every day utilize that outer suspension mounting point. So a lot of people don't even know it's there. But what it does is it allows the track to be wider in the front to minimize and square up the front track with the rear track. So what we did is we set the wheels up, set up the suspension points using the outer mounts, and we developed the body around the track. So what we didn't do, like a lot of other aftermarket manufacturers do, is they make a beautiful body, and they're like, okay, let's try and figure out how to make the wheels fit the body. That's the incorrect way to do it. The correct way to do it is to set up the perfect track and build a body around that track. So this is an example of, so this is the rear fender right here. You see on the part of the rear bumper, you can see how much wider it is. This is the original rear bumper before we've actually extended it. And this is the fender flare that we added. This fender flare is CNC ABS plastic. We actually then join it into the factory rear quarter panel, and we start clay surfacing it to blend the fender flare in. Let's go back there for a second. So that width, this is about 6 inches wider than the factory Carrera 2. And you can see the blending surface. This is a key design feature that a lot of Porsche purists notice, is this fender crease right here where it goes into the wheel liner. That is a design signature of the Porsche 993, and we made sure we captured that, and we scanned that, and actually brought that fender flare out with the exact same radius and surfacing on the inside. And you can see right here, this is a photo of, the left side is the factory front fender, and the right side is the new fender. So we attached the front fender flare, blended it into the front fender, and you can see the difference in width between a stock and the new revised front fender. Here's another photo of the fenders showing the amount of width here. We've clayed all this up here, and this is blended in right here, and we're just getting started on blending the side skirts to meet that width on the back. We struggled a lot with the rear bumper design, because what we had was, when you have the European license plate, it's nice and skinny and not very tall. But as soon as you put like a California license plate or US license plate, the bottom of the license plate was just too tall, where it would sit too close to this exhaust. So what we had to do is we had to lower the exhaust and the exhaust tip to create enough painted surface between the license plate, US license plate, and the exhaust, just so it was more of a visual design thing than anything. And we had initially had this all completely flat, but we actually decided to add a vent right here. And we did this for two reasons. One is for functionality. It actually helps escape heat out of the engine and the exhaust. You can see right here, this is sort of, we clayed up this one side and left that side solid. We were like, okay, what do we do? What looks better? And we decided on the left side to keep it more functional and modern. And you see also here, we're also playing around with the way the license plate is cut out. So this one is slightly more angled. This is sort of reminiscent of a 997 GT3, and this side right here is more squared off. It's really more period correct for the Porsche 993. And we had decided to go with a little bit more modern design and cut that license plate at a 45-degree angle. The other design feature you see here is the S-curve. We don't just flare it out and go straight across. We sort of taper it and blend it in so it looks more organic and flows better. This is the right side is the clay model part, and this is the section that we still haven't done yet. And the reason we haven't done this is what we do is we create a center line on the center of the bumper. Then we design one side, and we'll laser scan that side and then flip it to the other side. And the reason we do that is if you do this 100% by clay, by hand, you can't get absolute perfect symmetry. So we wanted both the left and right side to be completely technically symmetrical. So we scan one side and flip it around and apply it, and then CNC machine the part and make the tooling. So a lot of the design cues you see here right now, there's some kickback to the Porsche Carrera GT, where you have this center mouth opening right here and this opening style right here. And there's a highlight that we added right here to sort of hark back to the Porsche Carrera GT design. And then this, we used a European turn signal light, which is a little bit longer. And we created, this used to be where the fog light sits. We removed the fog lights and we created a hole here, and our new radiator sits now completely flat facing you like this. So this actually generates air directly into the new front-mounted oil coolers. Some more photos of the rear wing design. It was a very challenging part because the rear wing is very, very organic. There's a lot of round shapes to it. And what we started with GT2 factory wing, and we sort of used a lot of the functionality that Porsche had engineered into the GT2 wing and revised it and improved it. So on the next slide, you'll see the shape is a little bit more aerodynamic than the 993 GT2, and we've sort of taken inspiration from a military jet engine sort of look, and we've revised the angle of this to allow more airflow to come in. And we created this line break right here because when this was just completely smooth, it just looked too heavy. It looked kind of like a water jug. So we created a line break and put the right radius in just sort of to break up that space. And then you see these points are really where the wing mounts go. And you see 3 holes right there. That's the 3 different mounting points that you can adjust the attack angle of the wing based on the kind of track that you're on. So this is a close-up of the rear bumper, and you can see that essentially the entire car is made out of carbon fiber. The only parts that are not carbon fiber is really the doors, because the doors have a side impact beam built into the door. And for homologation reasons, especially when we ship it out all over the world, we want to make sure that the car has all the safety homologation in place. So we left the doors alone, but the doors are about 100 pounds each, Jeff?
Just under.
Yeah, just under 100 pounds. So if we made carbon doors, we could probably save almost 200 pounds in the car. But yeah, the roof is carbon fiber. The entire car is made out of carbon fiber. What we also do is we create carbon Kevlar on certain areas where we want more flexibility. But the rest of the part is, it's all pre-preg autoclave carbon fiber, 100% made in-house. This is the roof. So the car, a lot of 993s that got imported into the United States had the sunroof. So what we did is we removed the sunroof because that saved about 45 pounds. And we manufactured our own carbon roof skin. And you see right here, we created these pins, these locators. And we leave just enough of a border around it to be able to blend it in. You don't want to cut it all the way to the edge because that'll actually flex the body and twist the car. So we place the carbon roof on the car, we create the locators, and then we use this high temperature epoxy glue that actually Porsche, BMW, a lot of these manufacturers use to graft and bond the carbon skin onto the steel body. This is a shot of the rear now. This is actually where the first production parts get installed on the car. So they're carbon fiber, we get it all primered, then we're actually test fitting it for the first time, making sure that all the gaps and everything are correct. We actually removed all of the rubber gaskets that are between the bumpers and the fenders on the car that Porsche used to have, because the gaskets do get old and they sort of turn white. So we removed all the rubber gasket and tightened up all the bumper gaps. You see right here, there used to be a gasket right here. We would remove that, and all these gaps are actually now sort of 991 2017 standards. The interior, this is where we start ripping out the interior, and I do not look forward to the next car because removing this carpet and the glue underneath that they used was absolutely a nightmare. It was a lot of work removing that carpet. But this is the initial beginning stages of when we start, we laser scan everything, and we're starting to replace all of the carpet and the interior. This is the first time we played with 3D printing in aluminum. So we've been doing 3D printing in plastic, but this is the first time we did it in aluminum. So what happens is you have a laser and powdered metal that will come in place, and the laser will start melting the metal and build up these layers all the way up to the headlight. And this blue area right here is sort of where the metal break-off is. So the 3D printer builds this section, and it's weaker because it's just acting really as a stand to be able to print out the 3D housing. But this metal printer can make titanium, magnesium, whatever metals that are out there. And this one was made out of forged aluminum. So this is the first prototype that we had, which we unveiled at Quail. And then we have a Gen 2 that we developed, which is a production version. And this particular headlight, what we did is we used to have 4 LEDs on the side of the projector. We got rid of that because this this projector had to grow because we wanted to use a bi-LED system. We wanted to skip the xenons because LEDs is really the latest technology. So we have to use a bigger projector housing and a new bezel. So we got rid of the daytime running light, 4 dots around it. And this is a aluminum heatsink, which is a separate piece, which has ventilation right here to reduce heat. And the entire housing is actually, the new housing is made out of carbon fiber. And we have a bezel right here that goes around the outer perimeter of the headlight, which is sort of a halo, which sort of harks back to like what Porsche does on the 991 series today. So this is the glass that we use to make the headlight housing. And it was quite a challenge because this glass is 5 millimeters. Yeah, it's 5 millimeters. And a normal windshield glass is 3 millimeters. So this company is based out of Huntington Beach, and he actually used to work for a company called Metal Crafters, and he does a lot of windshields for a lot of concept cars, a lot of production cars. And he said that this was the most challenging headlight lens he had ever made. So what happens is it starts off with a sort of rough circular glass shape that's completely flat. And then what you do is you put that glass into a mold, and you put it into an oven, and once it heats up, it has that sort of spherical shape of that Porsche lens. Porsche, being the obsessive German engineering company, they have a left and right side for the headlight lens. And there is only a 3 millimeter difference in the 6 o'clock position. I have no idea why they did that, but they're just, yeah, we actually have to label the lens because initially we had fitment problems with the headlights where we took the driver's side lens and put it on the passenger side headlight housing and it wouldn't fit right in. So we have to label it now and sort of figure that. This is the oven that the headlight lens is actually baked in. So on that lens, we actually have to break about 10 sets of glass to be able to have one pair. The failure rate is very, very high. So these are some of the components that we made. These are all CNC forged aluminum. This is the housing that has the halo ring that goes on the outside. Some of the bracketry. This is a ring that actually glues onto the headlight lens. This is a brand new LED, bi-LED projector and the carbon fiber housing that we manufactured to house all that. And that's actually the finished product right there. So this area right here lights up, and this has got a bi-LED headlight projector system. So on the interior, this car is really sort of a homage to the Porsche 993 GT2 RS had Porsche had made it. So we wanted to keep the car very, very sort of business and very, very performance oriented. So we used a lot of the materials that Porsche uses on current cars like leather, Alcantara, aluminum. Everything has to be sort of lightweight. We use a lightweight carpet that's actually used in aerospace. So it's the first time we've used a carpet like this on a vehicle. And we went ahead and designed inserts in Houndstooth. So there's a difference between Houndstooth and Pepitas. So Houndstooth is actually the more classic material that's used in the older 911Rs and Porsche's vintage cars. If you look at the new 911R, the 991 911R, they use a material called Pepita, which has a slightly different pattern, and it's actually made out of a seatbelt fabric to make it more durable. But this in particular, to be period correct, we went with Houndstooth, and there's actually a company in Belgium that has replicated that pattern almost exactly. So took a little bit of time to source that. And here is a scan of the rear seat. So the Porsche GT3, as you know, don't have rear seats because this is a performance car. So we wanted to also eliminate the rear seat for weight savings. There was about 17 pounds, I think, that we removed from removing the rear seats. And we laser scanned the back. So what we didn't want to do was just sort of carpet that back area. We wanted it to be lightweight and have that performance look. So we weighed the factory carpet and figured out ways to save that weight, remove sound deadening material back there to save as much weight on the rear. So we scanned the back of the car, and then we designed a rear seat delete panel. And this is actually, right here, this is actually 3 different pieces: the top parcel shelf, the back, and this bottom portion. And this is an ABS plastic machine part that we first test fit on the car, and we start trimming it and making sure that all the fitment's there. Once we verify it, then we'll actually make the tooling. We have all these sort of inserts in here to create strength. It's part of the design, but really it's for strength. And back here, we used to have speakers. Let's go to the next slide. We used to have speakers in the back, so you don't really need rear speakers. Rear speakers actually don't do much for sound. The front speakers actually are sufficient for sound technology. So if you look at all the modern cars, they don't really have rear speakers. So we removed the rear speakers. That saved about another 12 pounds, 7 to 12 pounds, somewhere around there with the wiring. So this is actually the production version of the rear seat delete. And we have extra carbon fiber reinforcement in this bottom section just in case we have like a heavier guy who decides to lean on it and we don't want it to damage and crack. We've got the fire extinguisher mounted in the back, and we've redesigned these side panels to accommodate for the rear seat delete. There's actually a cutout right here just in case you want to do a harness bar. And we also wanted to redesign the front, or the front trunk. So when you open the Porsche 993, you have a lot of carpet, and it just looks a little, loose and messy. So what we wanted to do was tidy that up a little bit and develop a carbon trunk liner that's lightweight and functional. So that's a scanning, and this is actually the production version of it. We have removed the spare wheel, and over here now on the production car, you see the electric steering pump that we have shifted from the back of the engine to the front. And we've developed new gauges with forged aluminum gauge bezel, which has 6 cutouts to sort of celebrate the air-cooled 6-cylinder engine. The new red line now is 7,800 RPM. I know Jeff is going to talk more about the engine with you guys. These are some concepts that no one has seen outside of PCA today. We are actually working on a carbon fiber interior door panel, and we have a new CNC machined aluminum door handle right here with a pull strap to sort of hark back to that sort of RS style performance door to save weight. This is the new seat that we're working on that we're going to release next year. This is sort of loosely based on a 997 GT2 seat. It's a non-folding, single, one-piece back carbon fiber seat. And we've taken elements of the 997 GT2 and sort of taken the seat cushion design of the 993 GT2 and made it sort of more period correct. So it's a kind of combination of both modern and classic lines. These are actually the key designs that we've been playing with yesterday. We just got this from our designer yesterday. So we're making a new key head. Instead of having a plastic key head, we are making our own billet forged aluminum key head. So we're playing with different key designs right now. And proud to say that the car is 63 inches wide in the back and 63 inches in the front. So the car is completely 100% square. And just going over the power to weight ratio. So if you look at sort of the more air-cooled generation right here on the left side, on the power to weight, 964 3.6 RS is 209 horsepower per ton. 993 3.8 RS is 236. So these are sort of in the 200s per ton, except for the Porsche 959, which is a turbo, that was 306 horsepower per ton. And then you go to the right side, you look at the 997.2 GT3, that's 307 horsepower per ton. 991.1 GT3, 327 horsepower per ton. The 991.2 one GT3 RS, which you see back there, is 347 horsepower per ton. And the brand new 991.2 GT3 is 344 horsepower per ton. So the largest horsepower per ton on a naturally aspirated side, outside of the 991 GT2 RS, is the GT3 RS, which is 347 horsepower per ton. And the Gunther Werks 400R is 352 horsepower per ton. So essentially what we've done is we've created a beast, a monster that has incredible horsepower, power to weight ratio. The new car, with all the weight savings, went from 3,170 pounds, and it's now sitting at 2,670 pounds. So it's lighter than a lot of air-cooled race cars that you see today. So this is how the car looked originally. It was Guards red with the tan interior. And after the transformation with a newer wide body, you can see it's quite a bit lower. And this is sort of the before and after. This is part of the team. We have an amazing engineering team. Jeff Gamroth, who's over there from Portland, Oregon, who's our engine builder. Kerry Eisenhower of Eisenhower Racing, he's a suspension genius. And Joey Seeley as well is also our suspension engineer. He's had a lot of Porsche racing experience. He used to actually set up all the cars for Patrick Long. And with these three guys combined, we have over 95 years of Porsche racing experience. And I'm going to turn it over to Jeff Gamroth, who is going to talk to you about the engine, the transmission, and the technical side of it.
Morning, everybody. Thanks for the PCA people inviting me. I appreciate it. A little bit about me. I've got a in just south of Portland, in a little town called Sherwood, Roth Sport. We shortened it up and put a racing on the end just for the sporty side of my business. Little background. Little of my background. Started working on 911s when I was 15. Went to college, decided to quit, work on Porsches for a living. And started working for 2 independent shops, did that for 15 years, then decided I got to do my own thing and build custom Porsches. And I've been doing that now for 20 years professionally. So during that whole independent shop and my own shop career, I was fortunate enough to have jobs with 2 professional race teams and have benefited from a lot of the experience I've gained over the years in the racing side of things. And that's led me to develop some of my own products for these engines and cars and learn a lot about the higher performance end of things. Because of my age and my experience, we now also do a lot of restorations on these old cars, which include also converting back race cars that have been built years and years ago, some of which we've actually built back into street cars now. So we used to take, like, one of the first cars in my own shop was an M491 Turbo Look Carrera. And it was a perfect car, 40,000 miles on it. We just gutted it. Took everything off of it, stripped it, welded a cage in it, turned it into a race car. We are now restoring some of those old race cars back to street cars. Obviously, as you guys know, some of the values are going psycho. So they're worth more as an original street car than they are a track car or race car. So part of my business is custom street cars, hot rodding, restorations, very little service and maintenance. It's almost all custom Porsche building. Mainly the older cars. We do a lot of GT3 work, Metzger-based, Getrag gearbox-based chassis building and engine building and whatnot. I got into building my own engine components and chassis components for some of these cars because there was a need, I felt, for some cooler pieces. If it wasn't made or wasn't available, or if there was just something that wasn't up to a level, a quality level, I decided to build it myself. So I've developed a line of products for these engines and some gearbox parts, some chassis parts, and some of you may have seen our ads in the Pano and Excellence. We started out with the original engine, and next slide, please. Took all kinds of parts off of it, probably 100 pounds less off the engine than, I wish I would have weighed the two engines. We're going to build more cars, so we'll have a chance, but I'm guesstimating about 100 pounds. The cost is significantly lighter. The induction system is significantly lighter. As Peter said, we took the power steering off the engine, which is a hydraulic pump driven by the camshaft, and we moved that whole system to the front of the car. So we shifted whatever weight, plumbing, liquid, reservoirs, pump off the engine and moved it into the front trunk using a Cup car electric power steering pump that they're currently using on modern Cup cars. We took the AC pump off the back of the car and all its related plumbing and all the rocker plumbing and whatnot, and we have an electric pump in the front trunk that is compressing the refrigerant. So it is now much cleaner and tidier. It has significantly less weight at the back of the car, so I don't know what the percentage is yet, but the original front to rear distribution is greatly improved because we've taken a lot of weight off the back of the car, and some of that weight is removed permanently, hence the 2670, and some of that weight is now moved forward. So I was in charge of the drivetrain, so engine, gearbox. The engine is 4 liters. Basically, the only part of that engine, the original engine, is the crankcase and some of the peripherals, the housings, the alternator, whatnot, the engine sheet metal and surrounding tins. The gearbox is custom limited slip, some internal strengthening, special gear ratios 1 through 6, additional stiffer mounting system. The clutch is standard 993 RS, single mass. So we save 20 pounds off the clutch right there, plus the moment of inertia that you get with you increase your rev speed by reducing mass of the flywheel and clutch. Some of the more fancy components on this engine are the fuel injection system, which I developed years ago based off what I learned from the 993 RSR race cars that I worked on. I made my own system. I have the throttles right here. Instead of having one throttle body on the top of the plenum and just a injector holder here, we've built 6 butterflies, one for each cylinder, and we now have just a plenum with an air cleaner on top. So this plenum now is at atmospheric pressure, sea level. When you move the butterfly up here, this whole plenum is now above sea level and has vacuum in it. When you open the throttle on a single butterfly motor, you have to wait for that low pressure to turn into high pressure for air to start moving, and that's the kind of the lag you feel on all the modern cars. You guys know what I'm talking about. They just don't have the crack, I call it, of a carbureted car or an MFI car, for those of you who know the difference. So we took and basically put throttles right above the valves, so the only part of the intake track that is under vacuum is from the butterfly to the valve, which is maybe this far. The atmospheric pressure is now in the plenum, so now as soon as you open the butterflies, you now have instant on, I call it, if you will. So that engine has a significantly improved throttle response for several reasons, not the least of which is the intake system. All the Cup cars, RSR, well, not the RSRs, any of the highest level Porsche race cars use this technology. We build all the billet parts, the fuel rails, the linkage, the fuel pressure regulator. The plenum's built in the United States. The throttles I have made in England. All the billet parts are made in Oregon. The engine management system we use is a standalone laptop programmable system made in Australia and then sold right here in California. A company called Motec. They build some of the best standalone engine management. We have in this particular car, we have an M600 ECU that has dual mapping features. So we can have 2 different maps at the push of a button. And we need that because we have a dual path exhaust system on the car. And that system takes advantage of the two inlets on the muffler to improve performance and have quiet sound. You can have your cake and eat it too, if you will. So sometimes you want to be quiet rolling through the neighborhood, and unfortunately that takes horsepower. And it also changes the map, the flow through the engine. So we have to have the ability to have an additional tune when we're in the quiet mode. Then you can push a button on the console and have the exhaust open up so that it's nice and powerful and has that ultimate sound. And we've used a GT3 center outlet muffler. The center section of an actual GT3 is what's on the back of that car. We've adapted our exhaust system to it. The cooling fan you see here is kind of a cool piece. That's a one-of-a-kind billet aluminum hard anodized piece that's been built in Canada by an aerospace company. That fan has been FEA'd and CFD'd and optimized in the blade area here for airflow and efficiency. And this fan is, the original fans are made out of magnesium and are larger in diameter and have curved blades, and that was done mainly for sound, to reduce the sound of the engine. The 993 turbo fan that you see here, fan housing and fan, was used on only the 993 turbos because that actually produces better airflow over the cylinders. And since we are at 993 turbo horsepower, approximately, we wanted the maximum airflow over the cylinders to cool and whatnot. So we chose to actually use this more state-of-the-art fan than even the original 993 turbo straight blade fan. This fan weighs the same as the original mag fan, but it's stronger and more efficient.
Did it drop when it went to the 996? Because the 993 sounds so much better.
Well, the 996 has no fan.
It doesn't have, well, obviously it's cool.
Yeah, but
okay.
there's no fan on that. That's because of the cooling. So
Aren't there ones that come on after a certain, if it gets too hot and you stop?
Well, on the 996 you have the engine compartment cooling fan, right, which just blows air out to keep the. This is for strictly air cooling of the engine. So a couple more shots of the billet pieces for fuel injection we use. We're using basically the original fuel system in the car, the stock tank, the pump and all that, and all the plumbing. We just have the proper connections to connect our fuel system to the chassis, and then we make our own wiring harnesses in-house, mil-spec wire, and proper connectors and whatnot. So it's very durable, very reliable. And this was all kind of born of all the years of experience in racing and finding out what fails and what doesn't. So we did a lot of work. We've got a lot of experience building components that will still hold up, through time. Like Porsche. Like we wanted to emulate what Porsche did. So we tried to we count quality as the top priority. These are a set of our headers we have designed. We've tested a lot of headers on the dyno. We build I don't build the headers. We would get prototypes. We'd make prototypes. We test them on our dyno, and we then have a company manufacture the headers in mass quantity for us. Mass quantity being 10 sets at a time. A cool part of this intake system is this carbon plenum, which is loosely based off the 997 3.8 and 4 liter GT3s from the 997.1 and 2 cars. With the exception of this air cleaner. That air cleaner is a company, the company that made that is based out of England called E. Venturi. That's state-of-the-art CFD, FEA, crazy technology design that has gone into making that air filter as efficient as possible and enhances the actual airflow into the plenum over just a conventional flat or curved filter. Because of the shape and the design of that, it actually has an acceleration effect to the air, a Venturi effect. So we decided to employ that. Now this probably won't be the perfect production part. This is a part from a BMW that we adapted to this because the company is actually going to work with us to develop the actual air cleaner for that car, which will then be ducted to the air inlets on the sides of the wing. So time constraints meant that we had to try this. However, it seems to be very well received because you just don't see a big, you know, Venturi thing like that on most of these engines. It's kind of a cool visual cue, and it does work. I mean, the engine makes very good horsepower per liter. This engine makes over 100 horsepower per liter for a 2-valve aspirated air-cooled engine. That's significant performance out of a motor like that. And part of it is due to the air cleaner, part of it's due to the internal workings of the engine. The gear linkage, all the shift linkage we make. That shift lever is under there is a special lever that shortens the throw, and we've tightened up all the rods in the shift linkage, so it's actually more GT3-like. The GT3s have quite a nice feel for the guys that own the actual gearbox, manual gearbox cars. They'll know what I'm talking about. So it's much more like the later cars. The 993s always had a spongy gear shifter, and we make products to fix that. That button there is the sport button. That's the exhaust path / map switch button that allows you to go from a very subdued tone to just an ecstatic tone. You know, when you're on the car, in the canyons, in a tunnel, whatever, you get really nice sound out of the car from the exhaust system. Here's a shot of my dyno room. Every engine we build goes in this room and gets put on this dyno. This is a pull of the engine, that engine. Right now we're loading the engine at full throttle, and then the dyno lets the engine accelerate. So that was about a 10-second pull from about 3,800 RPM to 7,800. And this is just to show the results. Many runs go into this. Every load point, every throttle position. You see it has a very flat torque curve. The green line is a fuel mixture, and the blue line is the horsepower curve. That engine room, that dyno room, was something that I put in my business in 2002 or 3 or 4, somewhere. It's a blur, but it's allowed us to do a lot of testing and development to actually put out products like this. We do a lot of work for people that we don't even ever see the car. So we run every engine, we put it in a box, we ship it to them, we can tell them that this is your horsepower, the motor doesn't leak, the motor is, you know, ready to go, put it in the car, and you're going to have a good result. So every engine we do gets that treatment. This was no exception. We did a lot of testing of different plenums. The exhaust mapping was, you know, doubled the amount of mapping time because we map it on loud mode, then we map it on the quiet mode, and because of the airflow through the engine due to the exhaust change, it actually affects the fuel mixture and the tuning, so we have to map both modes, if you will. And we use a laptop. In that room, there are cables that run under the floor to the control room behind the glass there, and allow us to hook up a laptop to the ECU that's running the engine. Like 3 or 4 computers in operation when you're running an engine on the dyno. You have the data acquisition for the dyno. You have the laptop you're tuning the ECU with. You have the ECU engine, and you have the computer displaying the data to you so you can analyze it and then make the corrections on the dyno as you see fit. And that's like the finished product, I guess. Let's see what else. Holley.
That's you, buddy. I've got you covered there.
Gear ratios.
Yeah.
Gear ratios are everything. The 993s don't have the greatest ratios. The splits are wide. This box was kind of a collaboration of parts that I analyzed and collected that are from existing air and water cooled cars, gear ratio wise. And we put the ratios in a computer, we analyze them. So we've raised first gear, we've moved it closer to second, we've shortened up all the ratios. The sixth gear that's in this car now is approximately a 5.5 from the original gear. That say you have your fifth, you have your sixth, we're about 5.5. So shorter. We didn't want to be too tall or too short, so the motor was revving at highway speed too high, but still wanted to have a nice tight box. There's a couple steel synchros in it in the critical gears. There's some beefed up parts. A chrome moly differential is in there to make sure that when somebody wants to drive this car hard, that the factory diffs fail and wear out and actually have broken on cars that have high horsepower. So this diff is bulletproof. It'll probably never wear out or break. Yeah, I mean, any questions anybody has? I got through this a lot faster than yesterday.
Would it be rude to ask what you charge for one of these engines?
No, I mean, it's up to those guys, but man, I mean, it's...
So the car is based on a Carrera 2 993, and the basic conversion starts at $525,000. The car in that spec is about $560,000 plus Sedona car. Sure. But you would have to supply a Sedona car. So the 400R is a conversion, it's not actually a car.
So you said about 525,000.
Yeah. The engine gearbox package is about 90,000. I mean, that's the reality. You know, we start with a brand new Porsche crank, 4-liter crank from Porsche, GT3 oiling pump, oil system. That has a GT3 pump in the bottom of the motor. For those of you who don't know, the GT3 pump has 2 scavenge sections. So a 3-stage pump, 2 scavenge, 1 pressure. The original pump was a stage scavenge, 1 pressure. So we are actually scavenging more oil out of the crankcase, which helps reduce drag and windage. It helps under heavy braking. That oil rushes forward. The oil puddles at the front of the crank. There's a section of scavenge right there to pick that oil up in the tank. The rearward scavenge section is still in play, so that when you're under expansion, that oil is still picked up and removed from the crankcase. Mentioned a little bit about the oil cooling. The front of the front radiator is straight ahead, 90 degrees to driving direction. Okay, the radiator is like this in cars moving front to back. The air has to turn 90 degrees to exit the oil cooler. It's very, very inefficient. We add a cooler on the left side, just like the original RSRs did. The original cars had 2 oil coolers mounted 90 degrees to direction. Still not very efficient. So I found from using these cars and owning them myself that the oil coolers really help reduce oil temps. So we've actually, because of the bodywork increase, we are able to not only splay them on a stock car, for instance, a stock Porsche bumpered car, you can move them out maybe 4 or 5 inches and splay them, which adds about 20 to 25 degrees of reduction in oil temp, based on my experience with my own personal car. Because of their new bodywork, we were able to actually move the coolers 90 degrees to driving, or perpendicular to driving direction. So now it's like an actual radiator, just like it should be. So this car, with the amount of power it makes, and oil cooling is a major part of the cooling of the engine, we were able to really reduce oil temps. And so we've got coolers run in series, 1 on each side. They're the actual original coolers, the original right side and a copy on the left. That allows us to maintain temps and durability and reliability and whatnot. Yeah, so a little more about the internals of the motor. I kind of blew by that. From the crankcase out, the rotating assembly is 4-liter, 80 millimeters, 0.4 stroke. We have custom connecting rods made by Carrillo to our spec, steel connecting rods. Porsche used titanium rods in those GT3 motors. They turn 9,000. We're not turning that because we have too heavy of a valve train and our piston assembly is too heavy because of the dome shape. So we have to limit our RPM to essentially 8,000, about 1,000 RPM less. So we can get away with steel rods, that we don't need the lighter weight rods. They're also 1/3 of the price of titanium connecting rods. So from there, we built custom pistons. We had Holley, which is, you know, the original manufacturer supplier to Porsche. We had Holley make the pistons to our spec. I have custom-made forged cylinders in 2.7 millimeter bore. So this engine is actually 4 liters, 102.7 by 80.4. The original Porsche 3.8 used a 102 millimeter bore and a shorter stroke than this, and that ended up only being a 3750 cc motor. Porsche actually rounded it up to 3.8. This is a true 4 liter at 80.4 by 102.7. 102.7 is the Porsche bore that they use on the water-cooled 4 liters. So I actually use some of Porsche's rings, piston rings, and I have my own pistons made for this air-cooled application. Again, the cylinders were forged. They're actually made in the UK by a company that does F1 level forgings and machining and whatnot. They're stronger than the original Porsche Holley cylinders. From there, the cylinder heads are made, actually cast and machined in the United States. They have a proprietary port design that I developed with this head maker to take advantage of my throttle system and whatnot. And again, the engine's an air pump. You have to get air in and you have to get air out and do a little explosion in between, which makes the wheels go round. So more air in and more air out equals more power and torque. So the heads are critical. We have special cams made by a company here in California that I've used for many years, and those are part of the, everything is a system. You know, you can't just put a crank in it and a set of pistons and, you know, put some fuel and spark in it. You have to kind of design the whole engine as a package to get the kind of performance and reliability that we're expecting out of this engine. So essentially, the rotating assembly, all the parts that go around and around, it has mechanical rockers in it instead of the original hydraulic rockers. The mechanical rockers will take the RPM, whereas the hydraulic rockers won't handle the RPM this engine makes, or the cam lift and profile. So got to go old school. Every 15,000, got to adjust your valves.
Did you mention the compression?
No, I didn't. These are these that I don't mention. No. In all honesty, we're running about 11 to 1, you know, so it's stout but not crazy. It's base level. It's a lot of the water-cooled motors are running higher than that now because they have essentially a much more efficient cooling system with water. So the management system is, you know, crazy good. The direct fuel injection and the variable cam timing and whatnot. So you can get away with a lot more compression on the modern engines. You know, to get this kind of power, you gotta squeeze it, you know, and light the fire. We're using our unique ignition system. I should bring that up. Normally, you know, the 993s and 964 36s all have a distributor in them, old school, with 2 caps on it. One set of cap, one spark distributor cap for the top set of plugs and one for the bottom set of plugs. And the distributor rotor, the second rotor, was a slave driven by a little tooth belt. Those belts fail. It's kind of funky, old school. Very heavy with the $600 set of plug wires and expensive distributor, and the caps, rotors, distributor probably weigh 15, 16 pounds when it's all done. We got rid of that whole ignition system and went to small little high-performance motorcycle coils. They're called pencil coils. There's 12 of them, one for each spark plug. They snap right onto each spark plug and are driven by 4 igniters, the little circuitry that fires the coils, which is controlled by the ECU. So we've reduced the weight of the ignition system significantly. Those 12 little coils and the igniters are probably 6 pounds, you know, compared to what we took off. So again, weight savings, part of that whole horsepower to weight thing that Peter was mentioning. And really off the back of the car, it's the key to why this car drives the way it drives. As you guys will come to find out in the readings in the future here, so far the automotive journalists that have been in this car are are blown away by it. I drove the car on, I think, about the October 24th, right before the SEMA show, after we just wired the engine up. I shipped the engine down in a crate to a friend of mine's shop down here in California. We plugged it in, wired it up, turned the key, fired it up, went out and put a little quickie alignment on it, and went out and drove the car. And, you know, we probably broke a few speed rules, but it's fierce. It's a car that is, it's hard to explain how much fun it is to drive a car that's really light and has the throttle response and what I would call the crack that car has. You know, the blip ability and the gearbox and the shifting and all that. It's a very analog car that is brought to this more modern level.